Hi everybody, the purpose of this video is to go over section 6 of chapter 6, and here we are going to use the techniques we've learned in chapter 6 to solve quadratic equations by factoring. So we are going to learn about this thing called the zero factor property, and we're going to use this property along with the tools that we've already had to actually solve quadratic equations by factoring. We actually aren't going to be doing this. So we can just make that go away. I still want the G. There we go. Okay, so let's get started. Okay, well, what is a quadratic equation? Well, a quadratic equation is a polynomial of degree 2 with a leading coefficient of a. It can be written in the standard form, which would be some number, leading coefficient a times x squared plus another number which we call the linear coefficient, or b, times x plus c, which is equal to 0. And the main criteria is that a, b, and c must be real numbers, and a cannot be 0, because if a is equal to 0, well, then you no longer have a quadratic equation, you have a linear equation. Now, the cool thing about a quadratic equation is that it graphs this thing called a parabola. And it turns out that if a, there it is. Here's my poor excuse for an axis. If a is greater than 0, then the parabola will face up like that. So that would be a greater than 0. And if a is less than 0, well, then the parabola would point down, just like this. So unlike linear equations, which is nothing more than, when you graph it, is nothing more than a straight line, then the quadratic equation actually has a little curvature to it, which makes it kind of interesting. Now, another thing about the quadratic equation is that it can have at most two solutions. For example, if your graph looks like this, then we have at most two solutions, and we call a solution that part of the graph, that value of x where y is equal to 0. So this right here would be a solution, and this right here would also be a solution. It's also possible for, for a parabola, for a quadratic equation to have exactly one solution, kind of like that, where it just barely touches the x-axis. There we go. And then goes all the way up, or possibly all the way down. And this is actually what we would call a perfect square. And then also it's possible for a parabola to have absolutely no real valued solutions. For example, let's use this parabola here. Since it no longer doesn't cross the x-axis, does not have what we would call a real valued solution. It actually does indeed have a solution, but however, that solution is a complex number and not a real number, and complex numbers are beyond the scope of this course. Okay, so what is up with this thing called the zero factor property? Well, as you might notice, as we see here, 6 times 0 would always be equal to 0, because you're multiplying it by 0. And we can use any number we want, or we can generalize it and just simply say that any number a times 0 will be 0. Similarly, 0 times 6 would also be 0, and this 0 times this monstrosity of a number would be equal to 0, or 0 times any number b would be equal to 0. So if I told you that the product of a and b was equal to 0, what could you tell me about a and b? Well, either a is 0, or b is 0. Or both could be 0. So for this product to be 0, one of these terms have to be 0. Similarly, if you actually had a quadratic equation and you factored it to x minus 2 and x minus 1, and this is equal to 0, well, then either this term would be 0, which implies that x would be equal to 2, or this factor would be 0, which would imply that x is equal to 1. And that is the power of the zero factor property. We can use that property to find both solutions to a quadratic if those solutions happen to exist. So how can we use this? Well, maybe the best way to show you is to do a couple of examples, which is what I'm going to do, because you know that I love examples. So here is example 1, and actually, as you can see, problems 9 and 10 are just like example 1. Okay, so here we have the quadratic equation, which has been factored. This is a quadratic equation in what we would call factored form. And it is a product of x minus 5 times 2x minus 7 is equal to 0. And we want to solve this quadratic. Well, this once again, this quadratic is solved for all values of x, which makes this equation true. And there are two. The first one is when x minus 5 is equal to 0. And the second condition is when 2x minus 7 is equal to 0. And this is an application of the zero factor property. Ran out of space. Okay, and then solving these two equations, we find that x would be equal to 5. So this one's a little more challenging. We would need to add 7 to both sides, which will give you that 2x is equal to 7. Divide both sides by 2, and you have x is equal to 7 halves. So 7 halves and 5 are the solutions to this quadratic equation, which is already in factored form. In our next example, we have a quadratic equation, but it is not in factored form. Okay, so the first thing that we have to do, which is part A of your, which is the first thing that Haas will ask you to do, is to put this into factored form. Write it as a product of two linear factors. So let's go ahead and do that. Well, before we can do that, first we have to put it into standard form, ax squared plus bx plus c. And to do that, we would need to subtract 6x from both sides of the equation. And if we do, we will have 3x squared minus 6x is equal to 0. Now notice that this equation has a greatest common factor. Specifically, 6 can be written as 2 times 3, right? So they both have a common 3. They both have a 3 in common. This has 1x, this has 2 x's, so they both have an x in common. Consequently, it has a GCF of 3x, and we can factor that out. And if we do, we'll have 3x times 2 terms inside of a grouping symbol. The first term is going to be whatever we need to multiply 3x by to get 3x squared, and that, of course, would be x. The second term is whatever we need to multiply 3x by to get negative 6x, and that would be negative 2. And here we go. Now we have our two factors, and this would be your answer for part A. Now for part B, we need to solve this equation by factoring, or more importantly, using the zero factor property. And the property tells us for this product to be equal to 0, either 3x must be equal to 0, or x minus 2 must be equal to 0. Solving both equations, we'll divide it by 3 here. We just simply have that x is equal to 0. And then adding 2 to both sides, we have that x is equal to 2. And that would be the answer for part B in this particular case. Okay, so let's move on to example number 3, and here it is. Here we need to consider the following quadratic equation. It is x squared minus 8x plus 16 is equal to 0. And once again, we need to write this into standard form, but heck, it's already in standard form. Then we need to factor the left-hand side into two linear factors. Now notice that this is a quadratic expression with the leading coefficient of 1. So this is a section 6.2 problem. And in section 6.2, we want to find factors of 16 that sum to negative 8. Well, those two factors would be negative 4 and negative 4. Okay? As a consequence, we can rewrite this as the product of x minus 4 times x minus 4, which if you wanted to, you could write as x minus 4, the entire thing squared. This right here is what we call a perfect square. It will have exactly one solution, and it will only intersect the x-axis at one point, and that point is x is equal to 4. So to use the zero factor property, well, there's only here there's two factors, but they're the same, so we only have one equation to solve, so that makes life a little easier. And that equation to solve that would be x minus 4 is equal to 0. Adding 4 to both sides, we have x is equal to 4. And that is the only solution for this particular problem, because this problem is a perfect square. It kind of reminds me of Werewolves in London. It's the song Werewolves in London. His square was perfect. Okay, I need to get out more. Okay, this brings us to example 4, which is close to problem 6. And this one is actually an interesting problem because it highlights one of the more interesting relationships in quadratics, and that is the difference of two squares. For example, and what I mean is, if you have an equation of the form a squared minus b squared, it can be easily shown that that is equal to a plus b times a minus b. And you can do FOIL, and you can FOIL these two, and you actually see that is indeed the case. And that's what this reduces to. Now, for part A, we need to get this in standard form, and then we need to factor it. Okay, so let's go ahead and do that. We have 36x squared is equal to 25. Now we need to subtract 25 from both sides of the equation, and that will give me 36x squared minus 25 is equal to 0. That's our standard form. Now this right here is going to be a problem, is a section 6.3 problem, because we have a leading coefficient that is something other than 1. And so we're going to use the AC method. Okay, so we want to find the product of A and C, 36 times negative 25, which by the way is negative 900. And we want to find factors of negative 900 that sum to 0. Because if I wanted to write this more explicitly, I could write it as 36x squared minus 0x minus 25. Well, I could make plus 0x, doesn't matter. We want to find factors of 900 that would sum to 0. Though that means that those two factors must have the same absolute value. If they have the same absolute value multiplies to 900, that means those two factors must be square roots of 900. And it turns out that the square root of 900 is 30. So if one factor is 30, the other factor has to be negative 30. And indeed, 30 times negative 30 is indeed 900. So now we can replace 0x with 30x minus 30x. I can then use what we learned in section 6.2b. In section 6.1c, which is grouping. We can use grouping, and I can group these two together. That will be 36x squared plus 30x plus negative 30x minus 25. Okay, notice here, now I want to find common factors. Notice here that we have, this is 6 times 6, this is 6 times 5. So there is a 6 in common. We have 2 x's here, 1 x there. There's an x in common, so I can bring those out. And then that will leave me with a 6x plus 5. Now over here I have, well, a negative 6 and a 6 and a negative 5 in common. Well, let's not do it that way. I have a 6 and a 5 in common, and then I have a negative 5, and then I have 2 5s here, so a 5 in common. So I can rewrite this as 5 times negative 6x minus 5. All right, so I have another step, because notice here that this binomial is the negative of this binomial, so I can factor out a negative 1 here, and that will give me a negative 5 times 6x plus 5. Now I can bring the other one down. That will give me 6x times the quantity 6x plus 5, and now I have two terms with a common binomial factor. I can factor that common binomial factor out, and that will give me 6x plus 5 times 6x minus 5. Okay, so notice I had 36x squared minus 25, and it happens to be equal to this. Now also notice that I could rewrite 36x squared as 6x, the entire thing squared, minus 5 squared, and that is equal to 6x plus 5 times 6x minus 5. So really, this is nothing more than an illustration of this identity that I was talking about before, which is actually very useful when you encounter it. It makes factoring a lot easier. Okay, so right here is the answer to part A. So for part B, we need to solve the quadratic equation. We're going to use zero factoring, and that means that we need to solve two equations. The first one is 6x plus 5 is equal to 0, and then 6x minus 5 is equal to 0. Okay, solving this, we would subtract 5 from both sides. That will give us 6x is equal to minus 5. dividing by 6, we will have x is equal to negative 5 over 6. And then over here, I will have 6x is equal to 5 by adding 5 to both sides. Dividing by 6, I will have x is equal to 5 divided by 6. And that is our solution for example 4. Moving on to example 5, which is kind of like problems 3, 4, and 8, the most common one. Here you have a quadratic equation, and the equation is x squared minus 2x minus 10 is equal to 5. Our first thing we have to do is get this into standard form, and notice that this is not in the standard form with a 0 on the right hand side. And notice that we don't have that. To do that, we need to subtract 5 from both sides of the equation, and if we do, we will have x squared minus 2x minus 15. Now we have this in standard is equal to 0. Now we have this in standard form, and now we need to factor this into two linear equations. And notice that this is, since we have a leading coefficient of 1, this is a 6.2 type problem. So I want to find factors of negative 15 that sum to negative 2. And those two factors would be negative 5 and 3. So I can write this as x, the product of x minus 5 times x plus 3 is equal to 0. And there you go, we're done. So this is part A. Now for part B, we need to solve by factoring. Once again, using the zero factor property, we have two equations to solve. One is x minus 5 is equal to 0. The other one is x plus 3 is equal to 0. All right, for this one, adding 5 to both sides, we have x is equal to 5. Subtracting 3 from both sides, we have that x is equal to negative 3. And there we go, we're done. And I believe I have one more example before we go on to Hawks. No, that was my last example. So this kind of gives you a roadmap of what we actually just did in terms of doing this. First, we want to express the equation in standard form and set it equal to 0. There we go. Then we want to factor completely, just like what we did here. Okay, after we've done that, we want to set each non-zero constant factor, or each non-constant factor to 0, and solve the associated linear equations, which we did here, and we did here, and these are our solutions. Now, the one thing that we didn't do, which we probably should have, we should have checked them one at a time to see if it works. Well, if you did, you would have 25 squared minus 10x, which would be 15, minus 15 is equal to 0. So cool, that works. And then 9 squared would be positive 9, and then minus 2 times minus 3 would be positive 6. That would give you a plus 15 again. Minus 15 is equal to 0. So they will both work. And that is it for the slide portion of this video. Stay tuned, and we will do a couple of problems in Hawks. Okay, well, here we are. We are at my dashboard. Let me get my practice thing going. Okay, I guess we're going to go ahead and start at question 4. So here we go. We have x squared minus 6x plus 1 is equal to negative 4. Remember, the first thing that we need to do is get this into standard form. That says right here. To do that, we need to add 4 to both sides. So adding 4 to both sides, that will give me x squared minus 6x plus 5 is equal to 0. Okay, there, cool. We're done with that. Now we need to factor it. Now, once again, this is basically a 6.2 type problem. So what I want to do is want to find factors of 5 that will sum to negative 6. And those would be negative 1 and negative 5. Negative 1 times negative 5 is 5. Negative 1 minus 5 is negative 6. So now I can write this as x minus 1 times x minus 5. Okay, I don't need to do the parenthesis again, or it's going to yell at me. So just use your mouse or arrow to bring it over, then x, parenthesis, x minus 5. You can hit enter, and I did it correctly. Okay, so now we can hit next to move on to the next one. And so now we need to factor it in our two solutions. Now, if you don't recall what you did, or if you didn't have it written down here, of course, you can hit previous step answer, and it will tell you what your previous step was. So here, we have the product of x minus 1 is equal to the product of x minus 1 and x minus 5 is equal to 0. So that is true if x minus 1 is equal to 0, or if x minus 5 is equal to 0. And that will only be true when x is equal to 1 and when x is equal to 5. Okay, so there you go. We will put a 1 in here, and then we'll put a 5 in here, and let's see if we're right. And we are. Cool. Okay, so we can move on and do some other problems. Okay, let's go ahead and do this one, since this actually requires a little grouping, and we'll probably end with this particular problem. Okay, so we have 3x squared plus 17x plus 8 equals negative 2. The first thing we need to do is to get this sucker into standard form. So we need to add 2 to both sides, and if we do, we will have 3x squared plus 17x plus 10 is equal to 0. Okay, now we need to factor this. Now this is a 6.3 type problem, so we need to use the AC method. Okay, so with the AC method, I want to multiply 8 times c, 3 times 10, which will give me 30. And then I want to find factors of 30 that will sum to 17. And those two factors would be 2 and 15. 2 times 15 is 30. 2 plus 15 is 17. So now I can write this as 3x squared plus 2x plus 15x plus 10. And now I can go ahead and factor this through grouping. I can make this one group, and then I can make this the other group. There was a 1 there. I just kind of like did that one out. Okay, so here we have in this group, the 3 and 2 aren't common. They share no common factors other than 1. But here I have 2 x's and I have 1 x, so I can factor out an x, and then I will have a 3x plus 2 left. Okay, over here, this 15 factors into 3 times 5, both primes. 10 factors into 2 times 5, both primes. So they both have a 5 in common. So I can factor that out. And conveniently, I'm left with 3x here and then a plus 2 here. Okay, so here now I have 2 terms with a common binomial factor. I can factor that common binomial factor out, and that will give me 3x plus 2 times the quantity x plus 5. And of course, all of this is equal to 0. And this should be my answer, unless I really screwed something up, which of course is entirely possible. 3x plus 2, x plus 5. There we go. And now going to the next part of the problem, I want to find the values of x that will solve this polynomial, that will solve this quadratic. Well, that will occur when 3x plus 2 is equal to 0, or when x plus 5 is equal to 0. Okay, well, this is satisfied when x is equal to negative 2/3, and this is satisfied when x is equal to negative 5. So let's put those bad boys in and see what we get. What I'm going to do here is I'm going to do my negative sign and then my forward slash, 2 up here, a 3 down there. No, that's not it. I guess I had to do a tab and then a 3 down there. They need to standardize their fractions. And then over here, I'm going to put in negative 5. And let's see if I'm right. Yay me, I am correct. And that is all I have for this particular video, or this particular section. Once again, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.